Kia ora, year 12 and 13. This is question 1E from last year's differentiation paper. So this is the excellence question in question 1, and it's a parametric differentiation example. So if you're confident with parametric differentiation, it's actually pretty straightforward to know what to do. It's not like one of those related rates of change questions where you have to stare at it for ages. So we're just given the following function. We're told a curve is defined by these two parametric equations. So remember that what that means is that t is going to affect x and t is also going to affect y. So indirectly there's a strong link between x and y. We just don't find it in the usual way. And what we have to do is to show that the second derivative of y with respect to x over the first derivative to the power of 4 is a constant. So it should be pretty obvious where we need to start. We need to find dy by dx, and then we need to find d squared y by dx squared. So dy by dx, when we've got a parametric setup, goes like this. We've got dy by dt divided by dx by dt. Now, if you are having trouble thinking about that, it's probably time to do some parametric revision, but it comes down to the chain rule. Dy by dx is equal to dy by dt times dt by dx. And we can treat derivatives, loosely speaking, like fractions. So that's what I'm doing there. So step 1 is to differentiate each of these things with respect to t. So what did we have to start with? Well, we had x was equal to t cubed minus 1, or plus 1. So dx by dt, sometimes just written as x dash, is 3t squared. And y was equal to t squared plus 1. So dy by dt is equal to 2t. Now, what does that give us? Well, dy by dx is equal to, I will write it with the shorthand because I'm sure you'll see that in quite a few places. It's y dash over x dash. So that gives us 2t over 3t squared, which is 2 over 3t. Okay, what about the second derivative? Well, what does that mean? Well, it means when x changes by a little bit, how does dy by dx change? So what we want to do is to take dy by dx and differentiate it with respect to x. But we can't do that, right? Because we have dy by dx in terms of t. So we're going to do the chain rule on it. So this is how you do second derivatives with parametric. This is done really well in old delta and I think in new delta as well. So we differentiate with respect to t and then we multiply by dt by dx. So what was dy by dx? Well, dy by dx was up here. And so we can write that more sensibly as 2/3 of t to the negative 1. Okay, so dy by dx is 2/3 t to the negative 1. I just fixed that pen up. Don't know why it's going bad. So this needs to be differentiated with respect to t. And that's really easy, right? It's just negative 2/3 t to the negative 2. So that's that bit done. And now we need to find dt by dx. So we had dx by dt, that was equal to 3t squared. So dt by dx is equal to the reciprocal of that. It's 1 over 3t squared. So putting all that together, d squared y by dx squared is equal to negative 2/3 t to the negative 2 times 1 over 3t squared. So let's clean that up. Now we're just about finished the whole question now. We've just got a little bit of algebra to do. So we've got negative 2 over 3t squared times 3t squared, which is negative 2 over 9t to the power of 4. So let's go back to the question and see what we had to show. Well, we have to show that this is a constant. So now we're going to substitute expressions in and work our way through. All right, so d squared y by dx squared divided by dy by dx to the power of 4 is equal to the following. So it's negative 2 over 9t to the 4 divided by 2 over 3t to the power of 4, which is one big mess. So let's clean it up. So it's negative 2, like that, times, well, what have we got here? We've got 81 t to the power of 4 over 16. And we can see that the t to the power of 4's simplify away, and we're left with negative 2 times 9 over 16, which is negative 18 over 16, or negative 9 over 8, which is a constant as required. So there you go. So as I said, it's a pretty straightforward excellence question in the sense that it's clear what you have to do, but you must be confident with parametric. I'm pretty sure that Education Perfect does the second derivative of parametric quite well, but if it doesn't, the Delta textbook definitely does. So it's a topic that is well worth you spending a little bit of time on before November. Thanks for watching.